Number 1, 2-2A, constant of proportionality. The table below charts time and distance traveled by Mr. J. Okay. Does the table demonstrate a proportional relationship? How do you know? The answer is yes, it does. Because 2 divided by 2 is 1. 75 divided by 2 is 37.5. And this one is 3 divided by 3 is 1. And 3 into 112.5 is 37.5. And 4 divided by 4 is 1. And 150 divided by 4 is 37.5. So I know because the constant, because the ratio of 37.5 to 1 remains constant throughout the table. There we go. Okay. Number 2, 2-1A, proportional relationships. The cheapest songs on iTunes are 69 cents, but can be as expensive as $1.29. If you bought 5 songs at $1.29, how much would you spend? Well, each song costs $1.29. And 2 songs would be $2.58. And 4 songs would be $5.16. So 5 songs, I could set up a proportion to do this. 129 to 1 is equal to 5 songs at X. Or I could just multiply $1.29 times 5 is 5, 4, 10, 14, carry 1, 5, 6.45. So 5 songs is 6.45. What's the unit rate? The unit rate is $1.29 to 1. Number 3, 2-1B, multiplying integers. Write each expression as an equation. Well, this equals 12. Negative times a negative is positive. 4 times 3 is 12. Negative 2 times 4 is negative 8, because a negative times a positive is a negative. Number 4, properties of numbers, 3-1B. Write the letter on the line that best describes each step. Well, this is where we start, so this is the starting expression. And what's different about here from here is the 8s have all been grouped together and they've moved the thirds around. So because these things are just moving, and both sets have been moving, that's commutative property. Now, what's different from here to here is now these things are grouped, and it's the associative property of addition that allows us to group things. And really, from here to here is a simplification, and then you'd add. So both of these answers are correct. But to get from here to this, we have to simplify, and to get from here to this, we'd have to add. Number 5, 1-2B, adding and subtracting rational numbers. Model each expression on a number line and write each expression as an equation. Well, I'm going to start with this. Subtract a negative, I'm going to add, so this equals 0.4. Now model each expression on a number line. This 4 occupies the tenths place. So my number line only needs to stretch from 0 to 1 because we're just talking about the tenths place. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we'll go from 0 to 0.4. Number 6, 1-1C, adding and subtracting integers. And this problem isn't about integers, it's about rational numbers. How do I know? Well, Sydney lives on the same street as her school and her friend Jeff. Sydney lives 3.5 blocks, and it's that half block that makes it a rational number instead of an integer because it's not whole. From her school. Jeff lives 5 blocks in the opposite direction from Sydney. Mark on the number line where the school, Sydney, and Jeff are located. Well, again, the school's at 0. It says Sydney lives 3.5 blocks from school. So you'll notice we've got 0 and a half and then 1. So I need to go past 3 to 3.5. And I've got to go back 5 blocks. So I'm going to use the halves and count 1, 2, 3, 4, 5. And this is Jeff. And this was Sydney. Okay. So we'll just go back this way. Okay. Now, we could have done this problem in reverse. We could have said she was at negative 3.5, and Jeff was 5 blocks in the opposite direction. So this would have been Jeff here, and this would have been Sydney. And the school hasn't moved. And that also would have been correct. So there were 2 ways to do this problem. We'll do the black pen first. So Sydney was 3.5 blocks from school. And Jeff was 5 blocks in the opposite direction, so that's like subtracting 5. And that gives us a negative 1.5. Now the red, Sydney still lived 3.5 blocks from school, and Jeff lived 5 blocks in the opposite direction, and that equaled a positive 1.5. And we illustrated that on our number line in red ink. Both of those ways are correct.